Okay, good morning. Welcome to
MathyMath156.
MathyMath156. So we're continuing our study of factoring sums and differences of cubes. And do you remember how x cubed plus y cubed factors?
X plus y times x squared plus x, or minus xy plus y squared.
Yeah. So in the x cubed plus y cubed, you get an x plus y that factors out, and then you have a minus on the inside. And today what we're going to do is take a look at the geometry of this for 3 cubed plus 2 cubed. So we're going to get x is 3, y is 2. So can you double check that this is got the camera?
It is.
Okay, good. So this should end up equaling 5 times 9 minus 6 plus 4. Because x is 3 and y is 2.
Mm-hmm.
So 9 minus 6 is 3 plus 4 is 7. 5 times 7 is 35. 27 plus 8 is?
35.
35, okay. So we should see, if we can understand the geometry, we should see 5 nines.
Well,
What would 5 nines be?
that would be this whole thing if you add back in these parts. It would be 5 nines would be a 3 by 3 by 5 rectangular prism.
Okay. And just by luck, have one right here. 5 high, 5 3 by 3s. Okay. Now, what are the 6s? What are the 5 6s that we have to take away? Where are the 6s?
Well, you could say those are 2 of these layers. Like, here's a 6.
There's a 6. So in what case, what's the 3 and what's the 2?
So 3 long, 2 wide.
Okay. What's the 3 and what's the 2 over here in our original one?
3 is the side length of the big cube and 2 is the side length of the small cube.
Okay. So where's the 2 in the 3 plus 2 here? Which way does it go?
It goes up.
Up. Okay, so what were you doing with the 2 over here?
I was making it go this way.
Okay.
So we can say the 6s are this 2 by 3.
Okay.
Like that.
And if we take away 5 of them, we've got
That's 3
1,
of them.
2, 3, and then I'm going to do exactly what I did yesterday. I'm going to take those away, and I'm going to represent the missing 2 taken away by negative cubes, which are going to say are orange. Okay.
And then
Now we have to put in 5 4s.
which,
So where are the 4s?
well, 3 of the 4s would cancel out these.
Okay, where are the 4s? Where are the 2 by 2s?
Like this. 1, 2, 3, 4.
Okay.
So those are canceled out, and then you have 2 4s left, which make this top part.
So this turns out what we have taken away here, the negatives, are 3 4s, 2 by 2s there. And I didn't bring over the 2 remaining 4s that go on top, so I'll just make them real quick. And so we put those 4s in, and there we go. That's what we have left. So it's interesting to think about whether this would work in general or not. What's going to happen is we're going to get our stack that goes x plus y times x squared high. Then we're going to take away x plus y times an xy, like these 6s that we took away here. What's going to happen, we're going to have y of them, negative y here, and they're going to be x long. Okay, so we're going to get we're going to get their y high, because we already knew that. They're y long, so those are my y squareds, and I have x of them, and then I need to put in y more, and then that's what we get there. This is a little harder to see
Then the subtraction.
and also it's a little harder to see than the x cubed plus 1, but it works. It ends up working. Do you see the x squareds here?
Yeah.
Or the y squareds, I mean. There they are. So it's pretty interesting. It's pretty interesting that x cubed plus y cubed factors, but x squared plus y squared doesn't factor. That's an interesting difference. So what do you think? What do you think about the geometry of these things?
Pretty interesting.
Pretty interesting. Yeah, I think so too. All right, good work, hon.